notes today, like I said, it's going to be very important that you go ahead and get everything down just as we put it up here today. There's going to be quite a bit of work involved in some of this. But I think if you understand the rules that I outlined for you here, or outline, I guess I should say, I think this will make pretty good sense. What we're going to start looking at today is tying some of the algebra concepts that we've had for solving equations into some geometry. And the idea basically is going to say something like this. We're going to start putting unknowns in for lengths down here. So instead of having like a 7 and a 4 down here in this rectangle, we might have an x plus 5 and then a 2x up here. But the idea today is this. How many of you guys have used a formula before, say in a science class? Have you used formulas in science? Give me an example of a formula you might have used in science.
Speed and velocity.
Speed and velocity. So the speed is equal to the distance divided by the time, isn't it? Is that right? Okay, velocity is equal to distance divided by time. You've talked about that formula at some point, haven't you? Yeah. So if you knew a distance traveled and a time, couldn't you plug those in to figure out a speed or a velocity? Okay, so a lot of what's the principle in science of plugging numbers in for formulas is going to be very similar to the kind of way I approach this today. And guys, what we're going to start talking about today is this. We've dealt with stuff that have involved areas all year. And again, we're going to kind of revisit this idea of finding areas of parallelograms, triangles, and trapezoids. And we've got a bunch of formulas for those. So I guess the first thing I'm going to do is start with parallelograms. Up here, I've given you a formula for the area of parallelograms. What is that formula? What's it say? Area of any parallelogram is going to be a base times a height. Okay. Now, these three shapes up here are examples of parallelograms. Okay. A rectangle is considered to be a parallelogram. A square is a parallelogram. What would I call this thing? A parallelogram, right? Okay. As when I talk in terms of base and height, what angle is assumed between a base and a height? 90 degrees. Okay, always 90 degrees. So in this example right here, you might have say this is my base right here, which I'll call B, and this is my height right there, which we'll call H. All right? Understand this in squares. Sometimes they call squares the letter S, but understand that in a square, this is simply your base, and this would simply be your height right here. Okay? That would be your base, that would be your height. Then a parallelogram, guys. Is this slanted side my height or not? No. My base is down here on the bottom. We can say, yep, that's a base, but my height has to form what angle with the base? 90 degrees, right? First two shapes, we had 90-degree angles down here, didn't we? Okay, but in this one right here, the height would be something that's on the interior, where the height is perpendicular to the base. So your height might be right here. So just kind of refreshing your memory with those, and I think that we've got that down really well. So let's jump into what we're talking about today. Okay. One thing I'm going to tell you to do today is this. Anytime you start these problems, always, always, always figure out what shape you're working with. Number one. Always, always, always figure out what shape you're working with. Secondly, once you know what shape you're working with, write its formula down. And once you've got that formula down, we're just going to substitute stuff in. It's very simple today. So I want you guys to set your notes up like I'm going to do it here. Right? We're going to kind of T-chart this out. So there's a T. Well, kind of a T, the top of the T. And down. Right? So you want to do the same thing to your notes that you have in front of you. Now we're going to kind of look at two examples. We're going to look at one example that doesn't involve variables, and then we'll look at an example that involves variables and try and figure out what the heck is going on here today. Okay? But I think if you pay attention to this and you've done your assignments up to this point, this will make total sense to you. All right? All right, let's rock and roll. Do your best to draw a parallelogram like I have up here. I'll do my best. Here's my best impression of a parallelogram. Ooh, that's pretty good. All right, that's pretty good, isn't it? All right, let's rock and roll this. I'm going to give this a dimension on the bottom. I'm going to call this bottom dimension 12 inches. I'm going to call the height that's on the inside of this 7 inches. Okay? Now, first question first. What kind of shape are we even working with here? Parallelogram. Okay? Now, I know that some of you would say, can I just take base times height to get an area? The answer would be yes. But what I want to start getting you in the habit of for what we're going to be doing today is this. I want you to write down your formula for the shape that we're working with. All right? And as I scroll back up top here, what kind of a shape is this again, guys? Parallelogram, which I spelled incorrectly, it looks like. Yep, I did. And then the area would be a base times a what? Height. So I'm going to abbreviate my formula right down here. Okay? Let's find the area of this parallelogram using the formula. I'm going to write the formula down. I'm simply going to write down A is equal to BH. Okay, A equals BH right there. All right? Simply means my area of that parallelogram is going to equal a base times what? Okay, so let's plug in what I know. Do I know the area right away? I don't, do I? Don't have a clue what the area is, so I'm going to leave that as an A. All right? Do I know my base length? What is the base length?
12.
So what can I substitute in for the variable B? 12. So go 12 times, do you know the height? 12 times 7. Okay? Somebody want to punch that up for me? 84. Okay, we're talking in terms of an area, so what kind of a unit will an area always have? Square inches, right? So call us 84 square inches, right? So my area A is going to equal 84 square inches. We've looked at stuff like that before, haven't we? We've looked at stuff like that before, haven't we?
Yeah.
All right. Well, let's change the game, because this is what we're going to start doing. I talked about this idea of starting equations with unknowns in there as they would relate to geometric figures. So here's what we're talking about. Let's go ahead on the right side and sketch. Let's sketch another parallelogram. Okay? And let's do this. Let's go ahead and start seeing stuff like this. All of a sudden, let's let my base length be 4x. Uh-oh. And then let's let the height be, get it in here as best I can. Let's let the height be maybe 3 inches. Okay? Now, I'm also going to tell you in this situation as well that, and I'll put this in a different color, that the area of this is going to equal 48 square inches. All right? First things first up there, gang. What kind of shape am I dealing with? Parallelogram. Okay. That's the first question I'm always going to ask myself in these types of problems. What type of shape are we dealing with? You just said parallelogram, right? And I said earlier today that if you ever know what shape you're dealing with, write down its, what is the word? You just said it as? Formula. Okay, so let's write this formula down right now. My area is going to equal a base times a height. All right? I'm writing that formula down because that's the area formula for any parallelogram, right? Okay. Now, what we're going to start looking at doing is substituting some stuff in. So again, it's a parallelogram, right? And we know why we're choosing the formula we're using right now? Do we understand why we're using area is equal to base times height?
Yes.
Because it's a parallelogram. Are there any unknowns up there? There's an x up there, and that x is going to help us determine which of these 3 variables up here. Does this x help us determine the area? No, because the area is given, right? Does this x help us determine the base length? It does, doesn't it? Okay? So here's what I'm going to choose to do. We're going to plug stuff in, and we're going to go ahead and figure out what this unknown is in the drawing up here and use that to find your area, your base, and your height. So let's roll on this. Guys, do you have a value for A to plug in? What value? 48. So I'm going to say my area is 48. It's given to you right there. How about your base length? What are you going to put in for your base? 4x. Now anytime you have something with variables in it, I always want you to put parentheses around that. So substituting for the base, I'm going to substitute into base length in the drawing of 4x. How about your height? How about your height? 3. Okay. All right. So the first thing I'm going to do is this. We're going to go through here and figure out what the x value is. Okay. And then once I figure out the x value, we're going to come back and fill in all 3 values. And notice, 2 of them are already known. You know the area, you know the base, or I'm sorry, the height. Okay, help me out here, guys. On the left side, we have 48. On the right side, isn't this 4x times 3? What's 4x times 3 going to be in terms of x? 12x, right? Wouldn't the 3 times 4 right here be 12? So isn't that really 12 times x right there? Everybody agree 12x? Okay. Hey, I've got a question. Got enough information up there to go ahead and solve for x now? What step would you take? Divide by 12. And Savannah, when you do that, what do you get, kiddo? Ooh, 48 divided by 12 again? 4. Okay, so the x value here is 4. Okay. Now, big deal. All I've done is solve for x. They're going to say, what's the missing dimension? Okay. So here's what I want you to do when you get done with this. Yes, that x value being 4 is very important. Circle that. All right. In this original formula right up here, how many variables are there to this original formula? Well, there's an area, there's a base, and there's a height. Okay, so over to the right, when you get done, write down a is equal to, write down b is equal to, write down h is equal to. Guys, do we know what the a value is? Okay, the area a was what value? Okay, the area is still 48. All right, so we know the area's got to be 48. That's one unknown in this that we know now. That was given. How about your base in this situation? This is the tricky part. How was the base described in the original problem? How was the base described in the original problem? What did we put in for the base? Hello?
4x.
Put in 4x, right? Only you know x is what value now. Wouldn't that base now simply become 4 times the x value of 4 here? Would, wouldn't it? Wouldn't it? Okay, what's 4 times 4 going to get you? So what's that make the base length here then, guys? Okay, and then what was the height in the original problem? Okay, check this out. Yeah, we solved for x originally by plugging in the information that was given to us, but we think that if I have a parallelogram with the area of 48 and a base of 16 and a height of 3, check it out. What's 16 times 3 right here? My base times my height. Does that get you an area of 48? Works, doesn't it? Doesn't it work? Okay. So understand, yeah, you're plugging stuff in, you're going to solve for x. But when you get that x value, you have to go back in and substitute for your unknowns up here. Do you understand why this base length became 16 right here? Okay, it was 4x. Our x value that we got was 4, so this is really 4 times 4, which got you 16. All right, let's try another one. Let's look at the triangle example. You guys got this down? Yeah. I think if you can follow through this stuff, you'll be good to go. All right, let's try another one. Triangles. What's it say, first of all, in the area of any triangle? What's its formula? Half of base times height. So I'm going to just write it down here in all variables as a is equal to, how can I express half as a decimal? 0.5. So we're going to go 0.5 times the base times the height. So that would be the formula I always write down if we're using what shape here? Triangle. Okay? So in this triangle right here, I might have a base right here, and I might have a height right there. Do those appear to be 90 degrees apart the way I've written it? Those appear to be 90 degrees apart the way I've written it. Okay? How about here? Well, the base would be the bottom side. Where's the height going to be in this triangle? left side. They look like they're 90 degrees apart, don't they? Okay, so isn't this going to be my height on the left side? Okay, so my height is, I'll just put an H right here for height. Okay, so let's tee this out. Let's do an example numerically, and then let's one where you've got to solve for some unknowns. So tee this out. Ooh, what happened? Okay, let's just draw a nice little triangle. Here it is, nice little triangle. It's a pretty triangle today. You guys see my right triangle there? I like right triangles. Those wrong triangles make me mad. Right now?
Yeah.
You get them? Nice tie. Looking stiff today. Love the sweater vest. Jealous. I almost wore a vest today too. Should have. We could have been twins.
Yeah.
You ever seen the movie Twins with Arnold Schwarzenegger and Danny DeVito in it?
No.
We could be that role. I could be Arnold and you could be Danny DeVito. I'll be Bach. All right, here we go. Let's throw some values in here. Give me a height, somebody, in inches. 7 inches. Somebody give me a length or a base length down here.
18.
18 inches, all right. Okay, since I would be looking for the area of triangle right here, I got to use this formula. Area is equal to 0.5, that's the 1/2, times your base times your height. Now, do we know the base and the height in this? We do. So what are you going to plug in for your base length?
No.
Base length, you can plug in 18. We'll take half of 18. You're ahead of me already. Right? Who said that? You, right? Okay, well, you're ahead of me right now. Let's just plug in stuff first. Brianna, hold that thought. I'm coming back to you, okay? What's the base length in this game? What's the height going to be? Okay, so by formula right here, I've plugged in for the base and the height. That allows us to find the area in terms of its number of square inches. So what's the half of 18 going to get you first here, Brianna, again? 9, and then 9 times the 7 would be 63. So my area here would be 63 square inches, right? Okay. Well, I'm going to get tricky with this one. I'm going to draw another triangle right here. Right. How many unknowns are, by the way, in this formula? You need to know an area, you need to know a base, and you need to know a height, right? Aren't those the 3 variables in that formula? A, B, and H? Okay. Let's draw another triangle here quickly. Very similar to the one we just had. Oops. And yeah, actually that's going to work. I'm going to put a height right in here. Not a very good one. Okay, you guys see my height in here? Okay, let's get tricky with this right here. I'm going to call the base length down here 12. I'm going to call the height up here x plus 4. And I'm going to call my area of this triangle right here the following. Let's go with 36x. Okay. They're going to ask you to find the unknowns in this right here, okay? So the question is the following. What shape am I working with? If I'm working with a triangle, then I said, get your formulas for stuff down right away. So what formula should I put right after the fact that I've answered we're working with a triangle? Area equals, shout it out to me, Brianna. Half the base times the height. Okay, let's substitute our stuff in. All right. Do I have a number or a variable for my area? A variable. What is that variable that you're going to substitute in for area? Be careful. What is my area defined by up here? How many x? How many x is my area? So in for A, we're going to plug in what? So I have 36x equal to, okay, by formula, I have to bring the 0.5 down. How about your base length? Okay, when you substitute in for your base and height, put parentheses around it, so half of 12. How about your height? What's the expression for height? X plus 4. Okay. So everybody on 3, take a deep breath. 1, 2, 3. Okay. Why do I have 36x over here on the left?
Why'd you put 3? Yeah, why'd you put 3?
Oh, what was it? 4? My mistake. Hang on a second. Just making sure you were paying attention. That's why, Brittany. And you were. Good. Okay. Thank you very much. First mistake I made all year. I did say that yesterday? Well, I just turned 40 earlier.
Monday too.
I turned 40 earlier this week, so it's okay to forget that I said that now, right? Yeah. Right? Yeah. Okay. All right. Why 36x in on the left, gang? Why did I put that on the left? Anybody? It's my area. Yeah, plug it in. Okay. Why is the 0.5 here? Part of the formula for the shape we're talking about. Good. Why is it 12 right there? That's the base. Why is x plus 4 in parentheses there? That's the height. Let's work. Yes, let's work. Working's my favorite. What's half of 12 here? You guys agree that this part right here that I V'd out could simplify to 6? You guys really agree that this is 6 times x plus 4 right here? Oh, in parentheses still, right? 6 times x plus 4 there? Where did that 6 just come from, kiddos? Half of 12. Now, the x plus 4 is still in parentheses. And we know how to solve equations like this when we get to this situation. So help me out here. Yeah. Distribute. Okay? This is going to become 36x on the left. What are you going to have on the right here, Kyle? 6x plus 24 when I distribute. Everybody agree to that point? Yeah. Got about 2 minutes left. I'd really love to get through this example, and then we'll finish up on Monday with this. I told you assignment due Tuesday, right? Okay, so just make that mental note. Hey, I got variables on both sides. Do you want this positive 6x on the right now? Subtract 6x, right? Help me out on the left side. What's 36x minus 6x? 30x. What's that going to equal on the right? 24. All right, good. I'm going to move over here and finish up. I have 30x equal to 24, which means you'll take 24 and divide it by what? Divide by 30. All right, this is going to be a decimal. I'll just tell you that x is equal to 0.8. X is equal to 0.8. When you solve that, 24 divided by 30 is 0.8. Okay? How does that help me find my area of the triangle that we didn't know, guys? What's my x value here? 0.8. What would I plug in right up here? 0.8. So my area is 36 times what, guys? What is 36 times 0.8? What did it get? 28.8. So the area of that triangle is what? 28.8 square units. How would I find the height right here, guys? 0.8 plus 4. What is that? 0.8 plus 4. What is that? 4.8, right? Watch this right here. What was the base length? What did we say the height was? If I go 12 times 4.8 times 0.5, oh my goodness gracious me, look what it got me an area here. What do we get? Okay, again, Figure out your shape, write your formula down, plug in what you know, find your unknown, substitute back in. We'll pick this up again on Monday. You guys stay warm and have a great weekend, okay? Good job today, by the way, too. You guys are the best.